All right. Hello and good morning, everyone. Thanks for joining us at another Colorado LTAP Tuesday Tailgate Talk. Today we're going to be talking about electrical safety. We figured that was a proper topic the day after Valentine's Day because the sparks were going to be flying. And now we're here to talk about how you can protect yourself from that.
Thanks, Cody. All right, everybody. Welcome back to Colorado LTAP Tailgate Talk. Today we are talking about electrical safety because for three reasons. Males are mostly affected. Usually younger males are more prevalently affected by it. New hires with less than 1 year on the job are typically affected by it. And it is much more, the percentage is much higher for electrocutions in the transportation and construction industry. So you folks fall into that category. That is why we are talking about electrical safety today. So a study was conducted over a 12-year span between 1982 and 1994. Now, I know that's a long time ago, but um, they talked about electrocutions in the workplace, and I don't know that too much of that's changed in the 12 years or in the years since. Specifically, though, they studied 224 electrocutions that resulted in 244 fatalities. These 244 fatalities accounted for 7% of the workplace deaths during that 12-year span. Younger males between 17 and 70 were studied, and 64% of the deaths were for men younger than 35 years old. New hires on the job with less than a year accounted for 41% of the victims studied. And transportation and construction workers had the highest percentage of electrocutions at 56% combined. That's a lot of injuries. So there were five main case scenarios describing fatalities, and they were direct contact with energized power lines. So that's anything like you see in the first picture up here in the left corner. That was 28% of the deaths. Direct contact with any kind of energized equipment. Again, that was 28% of the deaths. Direct contact with power lines was another one. That was 21% of the death. Boomed vehicle contact with energized power lines. Down here you can see a picture of that. That's 18%. And then improperly installed or damaged equipment. This is an improperly installed wire here. Whatever it's connected to, it should not be like that. That was 17%. And then conductive equipment contact with power lines. And over here is probably a scenario in the far right that you will see in your workplace. That was 16% of the fatalities during that 12-year span. So I have a few general safety tips to help protect you from electrical hazards. First of all, never, ever, ever assume that a wire is safe to touch. Twice in my career working on the highway during a time when we were removing damaged trees after a storm, twice I was told that it was safe to go in and touch the wires, only to be seconds away from actually removing some of that debris to learn that they were live wires with, I don't know, whatever voltage goes through those wires. It's a lot. It would have killed us. After that, I always made sure I saw somebody put a meter on it so that I knew for myself that it was safe. And I asked them to touch it first. Sometimes they would, sometimes they wouldn't. Um, Keep a 10-foot distance from live wires when you're working. Unless you have special training and special equipment, resist the temptation to go in and cut that last branch, remove that last tree. You're always going to feel that it's just going to be that one last thing to finish off the job. Don't do it. Those are the times when you're most at risk, and just don't do it. Always look up too before you're starting any kind of work with long objects, any kind of ladders, pole saws, backhoes, any bucket, anything you put up in the air overhead. Make sure you look first, especially when you're working at heights on scaffolds in a man lift or even on a rooftop or even right in the back of your truck. Never operate electrical equipment in water. Damp areas, if you're in them, only use a GFCI protected equipment. So ground fault circuit interrupters, that's what GFCI stands for. They will automatically open the circuit when it detects an abnormal current, and that will prevent the electrical shock. Portable adapters are available for equipment. Most of you are probably familiar with these types of, the ones you see here, these types of GFCI plugs. Test them regularly. They've got, test process built right into them. To do it, push the reset button. On many of these devices, it's red. However, in some cases, the button might be the same color as the outlet. Sometimes they're all the same color. But then plug something in, like a lamp or a tool or whatever, and then press the test button. If the little light in the corner goes out, then it was a success. If the light stays on, then something's been damaged. So you need to replace it. Um, and anytime you see soot around sockets, and you'll see this in the workplace quite a bit, you'll see this in homes quite a bit. This means that the circuit is overloaded at some point and it's sparking whenever you the plug in or take the plug out, and that's dangerous. So look for soot around the plugs and replace them if you have to. Unless you're a licensed electrician or specially trained, electrical cord repairs are not allowed. And look at these here. I know you've got these in your workplace. I've seen them every time I go into a shop. If you've got something like this in your shop, get rid of it. You're asking for trouble. Don't let your employees do these self repairs unless they're trained and know what they're doing. It's not allowed. Made repairs on electrical equipment is not allowed. Stay away from any kind of fallen wires. They can energize the ground around them and they'll find a path to anybody or anything nearby. If you find yourself in an area where the ground is energized, you need to do what they call a shuffle walk. Don't let either foot lose contact with the ground. You need to stay completely grounded, stay connected to that ground. If you even pick up one foot, uh, you're going to let that current get you. You just kind of slide your feet away from the source of energy if you can. If you're in a vehicle, stay in a vehicle. If you see something like this, if you're approaching it in a car, I know of one incident where somebody actually got out to help, and the wires actually fell on the car, and the minute that person touched the car to see if the driver was okay, they were electrocuted. So watch out for anything like that and think twice before you approach anyone that's been in a crash where the wires are on the car. That's a particular hazard for most of us that are out there. We may be the first ones to encounter these crashes. So some electrical PPE is rated specifically for working around electricity. Make sure you have the right kind for your work. Here's a basic checklist to prevent occupational electrocutions, and it is not all inclusive. So first of all, make sure employees who are exposed to electrical hazards are trained and have proper PPE and tools. That means safety glasses, face shields, hard hats, safety shoes, insulated rubber gloves with leather protectors. These are usually the gauntlet type gloves, not the ones you see here in this picture, and some kind of insulating sleeves and flame retardant clothing. So I like to play this what's wrong with this picture game. And after I put this in, I realized there were a lot of things wrong with this picture. But he's generally wearing the PPE. He's wearing the flame resistant clothes. He's wearing the shield and all of that. But there are other things wrong with the picture. So let's not go there. Um, Implement lockout tagout procedures. This is another thing you can do, and train all your employees. Make sure employees know the location of electrical hazards and how to avoid them, right? Anything in your shop that presents a hazard to an electrical hazard to people, let them know. And it should be part of the orientation that you give to your work site, and it should be included in any kind of PPE training that you're giving your people, whether initially or on a regular basis. Implement safe practices to prevent these electrical injuries. De-energize live parts. Anything that you've got that's been energized, make sure that it has been de-energized, and discharge any capacitors, and especially use lockout tagout. You can see an example of lockout tagout right here. If you do not know what lockout tagout is, you can look up. I'm going to give you some resources at the end for the OSHA quick cards, and you can look that up. But make these practices part of the safety culture of your workplace. Some standards for equipment testing. So if you're using any of these bucket trucks, if you're putting any aerial equipment up there, you need to use dielectrically rated and regularly tested boom equipment. You can't do these in your shop. You need to send these out. They have to be done by specially trained people. Don't ever run the wires or any kind of wires across your dielectric boom. Um, Make sure that your equipment gets tested on a 12-month cycle. So all of this, it's regulated. You'll see the two regulations up here, ANSI A92.2, and then the Code of Federal Regulations, the OSHA regulations, which is 1926.453. ANSI usually is what private industry, public uh, organizations rely on, and CFR is what covers private, but they all are the same. So um, make sure you get them tested on a regular cycle every 12 months to verify the dielectric resistivity and detect conductivity changes in its insulating section. So you're going to figure out you're going to find out whether it's still safe to operate. So because over time these things will degrade, and it'll ensure the safety of the operator and anyone working or walking around the operator. Okay, so electricity will cause an entry wound and an exit wound, like a bullet. It will travel through the body and burn from the inside out all the way through the entire path that it travels. It keeps burning until the heat dissipates. So most of the injury from electrical shock or electrocutions, like you see here in this picture, you'll find an entry wound, and then like a bullet, it'll be small, and you'll find a larger, sometimes, exit wound. And it will damage your body all the way through by burning it. The photos of these wounds, I looked a couple of them up, and they were so horrible that I really couldn't put them on here today. But if you're a glutton for punishment, or if you want to see what that actually looks like and scare yourself, go Google images of electrical injuries and you'll see them. In addition to causing this kind of an injury through your body, it will cause or could cause heart attacks as well as strokes. It's very common for additional injuries to occur from falling or striking another object during the electrocution, right? You're going to be flailing around. You're not going to have control of your muscles or your body, and you'll hurt yourself. You could fall off a ladder, injure yourself on whatever might be around. Uh, don't take chances with electricity. Its bite is incredibly unforgiving. So, some points to remember. First of all, men younger than 35 with less than a year on the job are the most likely to be injured by electricity at work. Direct contact, either employee or equipment, is the most fatal. Never, ever, ever assume a wire is dead. Find proof before you touch it. And that's personal experience right there. The close calls and electrical hazards are the difference between life and death. Don't work within 10 feet of live wires. Most of you may have a policy in your agency that requires that you not work within 10 feet, but the temptation will be there, right, to do it. Resist that temptation. Discard and replace torn or taped wires and plugs. You are not in the electrical business. It is not your job to repair them. Use properly rated PPE if you're working around electricity. Implement lockout, tagout, and the required training that goes with it so that you can be sure that nobody is going to use faulty equipment. And use properly tested and rated boom equipment every time. So I promised you some references for the information that I got here today. This is where it came from. OSHA.gov has some great stuff on electrical safety, and you can look up all of their quick cards. They also have some good stuff on lockout, tagout, and the laws that govern electrical safety. ANSI is the other one, and you can go back and look at the ANSI regulation up. So thanks for attending today, the Colorado LTAP Tailgate Talk. I hope you found the electrical safety topic helpful and that you're able to incorporate it into your daily routine. So many workers have been severely injured or killed at work by electrical currents and equipment, and we know how to prevent these injuries and deaths. It just adds tragedy, adds to the tragedy when we know what to do and we decide not to, or we allow our employees not to. So do everything you have to make sure that you and your employers are not the topic of our next safety topic. Thank you, everyone, and stay safe.